Section 3.1 is where we're going to graph quadratic functions. So remember, a quadratic function will give you a U shape. We talked about this in Unit 1, okay? Some basics about a quadratic function is that it will have this kind of form when you are looking at it in an equation. So ax squared plus bx plus c. So a, b, and c are just numbers. The true wording for what we call this U shape is a parabola. When you are graphing this parabola, we're going to find this line, which is called the axis of symmetry. Since it's a U, it's symmetrical across this line, meaning if I were to take this side of my U and I fold it over, it should line up nicely with this other side. There are a couple things you can find from your equation. We can use this formula to find our axis of symmetry. So we're going to use the B and the A numbers to find that axis of symmetry. We also know that the C number is always the y-intercept of your graph. Let's try and graph some of these. I guess before we get ready to graph them, it also wants you to utilize some of the vocabulary maximum and minimums. We've already touched on this before. A minimum is going to be that lowest point within your U. Your maximum is going to be that highest point when the U is inverted down. And whenever you are naming the minimum or the maximum, you are always giving the y coordinate of that value. You can determine if you're going to have a minimum or maximum based off your A value. So if your A value is positive, that's going to tell you your graph is pointing up, so you're going to have a minimum value. If your A value is negative, that means your graph is reflected down, so that's why you would end up with a maximum value. All right, now let's try and graph some of these guys here. So we're going to graph using a table and state the domain and range. So our function is x squared plus 2x minus 3. So the first thing is just, again, identifying some basic things. So in this form, I always have an A number, a B number, and a C number. Even if you don't have those numbers, they can be represented with a 0. Your y-intercept, remember, is just your C value. So I know my y-intercept would be at -3. To find my axis of symmetry, we again have to use that formula x equals opposite of b over 2a. So what that means is I'm going to take my b number, which is 2, and I'm going to do the opposite of it. So that's why it's -2. Then on the bottom, I'm going to do 2 times my a number, which in this case would be a 1. Then I'm going to simplify. So 2 times 1 is 2. Now I do -2 divided by 2. So my axis of symmetry would be at x equals -1. So over on our graph, what we would want to do is draw in our axis of symmetry at -1. Then my next step is I know my U shape is going to be symmetrical around there. So I know my vertex of my parabola has to lay on that line in order for me to have it correct. So to do this, you're going to make a table of values. So you're always going to start by putting this axis of symmetry in the middle because it's going to lie on the axis of symmetry. And then you're going to find x values that are above and below it. So if I'm at -1, if I go up, it'd be at 0. If I go down, I'd be at -2. We've already practiced making a table before, but just to reiterate, you're going to take this x value and you're going to plug it in to find your y value. So that's what you see me writing out here. This I typically just type in my calculator, so you don't necessarily have to write all this out. So once I plug in a 0 for every x spot, I'm going to get these y values. So what you have just found are 3 points that I can plot. So I came over here, I plotted 0, -3, -1, -4, and -2, -3. Notice that my U shape, once I've drawn it in, it's being symmetrical across that line, and that I should have these points being symmetrical across there as well. So you can double check to make sure you're on track there. We also still have to state the domain and range, just like we did in Unit 1. So remember your domain are all of your x values. So in this case, I would be using every x value possible. So I would have all real numbers. My y values would not be all real numbers because I see it stopping at this y value. So my y values would begin at -4, and they would be going greater than or equal to -4. Pause the video and try the next question. So in the next question, you should have found your function, -x² plus 4x plus 1. You want to start by, you can still identify your y-intercept, but it is not as helpful unless you have other points. So my y-intercept's at 1. In this case, I'm going to do opposite of b, so opposite of 4 would be -4. 2 times my a value, which is -1. So times the bottom, you get -2. Divide top and bottom, you get +2. So your axis of symmetry would be at x equals 2. So over on your table, that middle value should be at 2, and then you're doing 1 above it and 1 below it. So I did 1 and 3, and then I started plugging those in to your function up here. So everywhere where there's an x, you want to plug in those x values. So then I found my y values, and these were my 3 points that I can plot over here. So on your graph, you should have your axis of symmetry at x equals 2. Then plot the points, 1, 4, 2, 5, 3, 4. So notice that this ends up being a reflected parabola, and so I have a maximum value up there at 5. We also still have to identify domain and range. So you'll notice the domain for these will typically end up staying the same. So it'll be all real numbers. And then your range are your y values. So my y values are capping up here at 5, and then they're going below that value. So y less than or equal to 5. All right, folks, that's all we're going to do for this section, which is just graphing. So making sure we know how to graph using a table.